Here we have another example of a first order circuit. We're asking us to find V0 of t. Remember, in this chapter, that means it's going to be K1 plus K2 e to the negative t over tau. And again, we're going to go through the 3 time periods. We're look at before the switch happens. So I'll draw my circuit here. And remember, before the switch happens, you are in steady state. If you are in steady state, inductors are short, capacitors are open. And you always want to find the either voltage across the capacitor or current through the inductor, no matter what it is you're trying to find in the end. However, in this particular case, the thing we're trying to find in the end is the voltage across the capacitor, and so therefore we actually get to save a little bit of steps at the end here. So we're looking for that. We want to find this voltage right here. Well, I don't know, we can go and maybe do node voltage here, call that V. So then I would have V minus 9 over 6K plus V minus 0 over 6K plus V minus 0 over 6K minus 2 milliamps equals 0. We can clear out the denominator here. So then I would have 3V, and then 6 times 2 is going to be 12 volts, minus 12 volts is going to be 21 volts, so V is 7. And again, that is your V0, 0 minus, which happens to be your V0, 0 plus, which is 7 volts. Next time period we're going to look at is right after the switch happens. So once the switch happens, the entire left-hand side of the circuit becomes disconnected, and we don't care about it anymore. It's not going to affect the right side of the circuit. And so we have our capacitor. We have 6K, and we have our current source here. And we're going to have 2.5 microfarads, D0, 0. Okay, and so what we're going to do is we're going to figure out our Thevenin here. I mean, there's really not much to say. Our Thevenin is just going to be 6 kiloohms from this. There's just the one resistor at that point. And so we use our tau formula. Tau is R times C, is going to be 6 kiloohms times 2.5 microfarads. That's going to be, let's see here, 15 milli, so 0.015 seconds. And then the third and final time period, we look at infinity. When we're back to infinity, we are at an open circuit for a capacitor. And I want to find the voltage here at infinity. Well, in this case, because it's an open circuit, that 2 milliamps is all going to go straight through the 6 kiloohms, which is in parallel with the V0. So V0 infinity by Ohm's law is going to give us 12 volts. And so that's what your K1 is. So V0 of t is 12 plus K2 e to the negative t over 0.015. That then we can solve for K2 by knowing V0 of 0 is 7. So K2 is negative 5. And my final answer is V0 of t is 12 minus 5 e to the minus t over 0.015. And my units are in volts. Okay, so again, every time you have one of these problems, you're just really trying to find K1, K2, and tau. And you can actually do these in different orders if you want to. the t goes to infinity time, that's always how you're going to find your K1. The time after the switch happens is how you're going to find your tau, and then you're going to combine K1 and your initial condition to find your K2. And it's a very methodical process, but it's a lot at first. So like I said, keep trying these here. Work on ones in the homework, see how it goes, and let me know if you have questions.